The process of harvesting salt starts with collecting saline water either directly from the sea using man-made canals or by extracting groundwater by digging bore wells. The water collected is pumped through a circuit of canals and stored in large ponds, usually spanning across 1000 by 1000 feet, having a depth of usually 30 inches. This is done in order to attain the desired level of temperature, that is 24 degrees Celsius, and salinity of water. These ponds are allowed to evaporate over a period of 10 days, after which they have to be plowed. The ponds are plowed either manually with the help of equipment known as khamparas or using tractors as pulleys. This process is continued for another 10 days at regular intervals to break frozen salt layers and catalyze the crystallization process of salt to increase quality. Once the salt in these ponds are ready to be extracted, it is harvested using harvesters and the excess water is drained out through pumps. This harvested raw salt is initially stored in the form of smaller heaps besides the pond itself using excavators. Then it is either stored near the processing site in large heaps known as ganjas or is sent for further processing to the washeries immediately in large trucks.
Once the raw salt has been completely extracted, it is loaded in trucks and is transported to the washery, where it is dumped into a funnel-like structure called the hopper. The hopper passes the salt onto a belt conveyor to maintain consistent quantity. The belt conveyor further leads to a vibrating strainer that removes any physical impurities like big rocks or stones. This salt then falls into a slurry tank where it is mixed with both sweet and saline water of 24 degrees Celsius to form a paste-like slurry for the ease of washing. The slurry is then carried through a series of screw conveyors where it is constantly sprayed on by brine, which cleanses the salt and balances out the chemical impurities such as magnesium and calcium, hence increasing the salinity of salt. This slurry is then pushed upwards by the screw conveyors while the water falls down due to the gravity, hence getting rid of any excess water in the salt. This whole process is done in order to get rid of both chemical as well as physical impurities and extract pure salt. Although washing salt causes a loss of around 20 to 40% of the volume of the input, it increases the overall quality and the whiteness of the product. Once the slurry has been passed through the screw conveyors and pure salt is attained, it is transported to an elevated level using belt conveyors and is again stored in huge ganjas.
The pure salt is then transported from the ganjas to the refinery for the final phase of salt manufacturing. During the transportation, the trucks are weighed using weigh bridges which indicate the quantity of salt in each truck, which is important for measuring the desired output quantities. Samples are collected from raw materials used as inputs in the refinery to test them for chemical impurities. Once the trucks reach the refinery, the salt is dumped onto the refinery hopper. A belt conveyor takes this salt into a slurry tank where it is again mixed with brine for further washing. The slurry formed, also called as feed, is passed on to the elutriation tank where it is spun in a vertical direction wherein gravity is used to differentiate the slurry based on particle density. The heavier particles settle down to the bottom and are drained out. The lighter portion of the slurry is separated through the overflow from the top. This lighter slurry is passed on to a second wash tank through a slurry pump, wherein this whole process is repeated to further wash and refine the salt slurry. The third and final tank is called a thickener, wherein the mixture is further refined and thickened by extracting excess water from the slurry. This form of salt is now processed in a pusher-type centrifuge, which is a sophisticatedly engineered machine that ensures that the slurry is rid of any water and dirt to give out a moisturized form of washed salt, free of any physical or chemical impurities, onto a screw conveyor for further internal transportation.
A very important chemical known as iodine is sprayed onto the moisturized salt to add the special iodization qualities to it while being on the screw, hence called the iodization screw conveyor. This conveyor pushes the salt in the fluidized bed dryer to vacuum out any moisture remaining in the product. Hot air is flushed onto the moisture containing salt inside the bed dryer to turn all water molecules into vapor and attain dry, free-flowing salt. A machine called cyclone captures any salt dust that may be produced as a byproduct. A bucket elevator takes the output from the bed dryer to the vibratory sieves where further refining takes place. The vibratory sieves are essential screening devices that separate salt particles based on size. The sieve consists of one or multiple mesh screens mounted on a frame which separate salt into various grades. Ideal particles smaller than the mesh openings pass through, falling on a screw blender, while larger particles are removed. The screw blender ensures uniform mixing of salt with additives like anti-caking agents and other minerals. The screw rotates and pushes material forward towards the silo. The silo, a tall cylindrical structure, stores processed salt before packaging. It is equipped with level indicators to monitor salt quantities and temperature and humidity control systems. It also features aeration systems to prevent compaction of salt and maintain flowability. There are multiple discharge points that further feed different packaging lines. The packing machine automatically weighs, fills, and seals salt into packaging. Salt flows from the silo through a controlled feed system which has a weighing mechanism to measure precise amounts of salt. The output can either be packed into 50 kg or 100 kg jumbo bags or is dispensed into plastic pouches which are closed using heat sealing. Lot number printing is also done for traceability. Laborers further package 25 kg bags of these small pouches, which is further put on a crate and warehoused in nearby facilities using forklifts and laborers.
Tests are then conducted on the refined free flow salt to examine the whiteness and iodine levels in the salt. Machines like spectrometers and tests like iodometric titration are used in the process.